You get in bed. Test, 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 test. Test, test, test.
Hey guys, Chris Streaming Code. Today we're going to, today I'm going to start learning Godot. So for a while I've been using Unity. Then recently they kind of did some things that made me not so happy with them. So I wanted to check out Godot for a while. Now seemed like a great time. So thought I'd stream so you guys can learn along with me. So let's get started. Alright, so I was just going to kind of download it, have it installed, and then we'll just dive right in. But let's go ahead and just take a quick tour of it real quick. So the game I want to work on is going to be a 2D game, so we'll be worried about the 2D stuff. So I was just kind of reading through their feature list. It's pretty on par with Unity and Unreal Engine, the other two kind of big players right now, arguably bigger than Godot. The cool thing about Godot, though, is it's completely free, like open source. Unity and Unreal you can use for free, but then you get certain size and suddenly you have to start paying for it, and there's like Unity Pro, and so it's not really free. Godot is, which is cool. So checking out the 2D stuff, this is one thing that's really cool. Unity makes this hard to do, work in pixels as your unit. You would think making a 2D game, making a pixel 2D game, that'd be kind of obvious, but in Unity it's not always. You could do it, but it takes some work, so it's cool that they just kind of support that right away. Tile map editor is also cool if you're doing tile maps, so and then I'm a coder, so I always go look at the languages supported. So it does support C#, which I think ultimately I'll use, but I'm kind of interested in GD script. So they say it's kind of a Python-like, which also means it's kind of a JavaScript-like language, and I, of course, love JavaScript. So I think we'll play around with GD script today. Always fun to pick up a new language. So let's go ahead. We're going to go download. And one thing interesting is, so we're going to we'll download this. So you have the standard version and the mono version. If you want to use C# at all, you have to download the mono version. If you don't, you can just download standard. But I was reading somewhere, I think I was looking at like what scripts do they support page. Let's see. So yeah, I think I was on this page. So they mentioned too that you can actually mix languages, which is kind of neat. So if you work on like a multi-person team, you can have different people using different languages. They do have a visual script right now, but that's going away in 4.0, so we're not going to worry about that. Yeah, so let's go ahead and we'll download it. And also, interestingly, I discovered they don't actually have an installer. You just run it directly, which is kind of weird, but kind of cool. So we're just going to extract this, and I'm just going to rename it Godot 315. I like to keep the version in there because it's always handy to remember. And then I guess we'll just dump it on the desktop. And then I'm going to run this. And then I'm going to go ahead and pin that to the taskbar so I don't have to open that folder every time. Okay, so let's go ahead and get started. Would you like to explore? Sure, why not? Let's explore an asset to get started. That's always a handy way. Let's see. Let's find something 2D. Physics platformer. I'm not really building anything with physics this time. So let's look for... you know what? Let's look at the 2.5D demo. The 2.5D, if you've not heard of that, is where you basically have 2D graphics, but you kind of simulate a 3D space. So we call that 2.5 because really it is still 2D, but we kind of make it, because of how the graphics are drawn, make it kind of look 3D. So like a lot of tactical RPGs, like not the first Final Fantasy Tactics, but the ones for Game Boy Advance and stuff for 2.5D, I'm pretty sure. And a lot of other games in that vein, like Tactics Ogre. And some of the Fire Emblems, not the more recent ones, obviously, but some of them were. Also, like fighting games like Street Fighter and Mortal Kombat before they went full 3D, where like you kind of moved up and down. So all of those were 2.5D. So let's take a look at this. Please choose an empty folder. So we'll go. Let's make a. Actually, we'll work on the H drive. Nope, K drive. There it is. Okay, so we'll go. Let's make a new Godot projects in here. Godot projects, and then we'll make a demo folder. We'll throw any demos we do in here, and 2.5D demo. All right. Install and edit. That was quick. Alright, warning, unable to load add-on script path, blah blah blah. This might be due to a code error in that script disabling the add-on. No. Oh, okay. Not off to an awesome start. Okay, so let's see. How do we run this thing? Project. Debug. Oh, here we go. Play button. Access. Alright, see, I have my little guy there. Oh, neat. So I can move around space, turn around, and he hits a platform and he kind of falls down. Simulate 3D. That's kind of nifty. Okay. So, we can use UI. Oh, that's neat. OJ. That's pretty bad. J. I missed. Okay, so apparently you could die. Or not. Just fall forever. Poor robot, he's falling forever. Okay. Let's take a look then at what kind of they have going on here. So, we have the player, it looks like. Okay, so that's the... that's not the player. Okay, so are these script things? Yeah, this looks a lot like Unity. Platform map. Okay. Interesting. Okay. So let's go ahead. We'll just close this and we'll go ahead and start something. Project. Quit to project list. Okay. Alright, so let's go ahead and make a new project. So the game I want to make, I'll fire up Photoshop so I kind of include you into kind of how, kind of what I'm making so you guys can follow along. Alright, so make a new file, big file, that's a weirdly shaped file, new file, go with that. Okay, so when game I have planned, and this isn't just a demo game, it's one I'm hopefully going to actually like make and release. We'll see. But I'd like to. I've been kind of designing it for a bit, on paper at least, designing the system and stuff. So it's kind of a cross between cookie clicker or other kind of idle clickers where you just click repeatedly to do stuff. Although that's only going to be the beginning phase, and then pretty quickly, and you'll start automating bits and pieces, and you'll still be able to click to speed things along. And then kind of sort of like maybe if you've ever played Recettear, not sure if that's how you pronounce it or not, but it's a game where you like collect items and can you craft in that one? Oh, actually, you may not be able to craft in that one. Mine, you'll be able to craft items. Basically, you'll have kind of a couple different modes instead of trying to talk what it's like. We'll just show it. So we'll have one where you can basically sell items. So it'll be kind of like a storefront, and you'll have NPCs walking up, and they'll buy various items you can kind of sell. That's kind of how Recettear was. Or part of it, anyways. There was more going on there too. And then you'll have, so that'll be the call that the shop scene, and then you'll have the workshop where there'll be various stations. I don't know what that's supposed to be. I drew a really wide person. You'll have like a blacksmith stand. That's an anvil. Beautiful. You'll have people. The clicking part. Well, you'll start off and you'll like click to do this yourself, and you'll handle selling directly yourself too. But eventually, you'll hire staff, and they'll kind of automatically work on things so you can craft. And there'll be a whole bunch of different workstations. Have a whole list of them, and so there you'll craft things, and then you'll have the gathering bit. So this will be like there'll be a farm where you can like grow crops or raise animals for those products. And there'll also be like mines where you can go gather ore and other kind of natural materials like that. And then there'll also be dungeons, which in this game you're not gonna be exploring the dungeons, but you'll have adventurers who will who will go in the dungeons and explore for you. And you'll like outfit them with items you craft and get adventurers, and they'll go in there and do stuff. So dungeons, and there you'll get like magic and I can't spell dungeon. D-U-N. Now anything I write is gonna look weird. D. Yeah, there we go. Okay. So you'll get like magic items from there and monster parts and stuff like that out of dungeons. And then you'll have trade routes. And this will be, you'll send off wagons either filled with items to buy or to sell them at distant lands, in kind of bulk, so you'd get less money per item than you do here, but you'll be able to send like lots of items, and also to buy rare items from other lands, and you can do both in the same trip too. Um, and so all of these will have like a clicking element to kind of speed it up, but you'll also have skills and stuff. City here. So, behind all of this is a whole boatload of data too. So we'll have to create systems so we can easily edit that data. So that's kind of the project going to work on. So let's go ahead. Why don't we just go ahead? We'll start by just kind of to play around with the UI stuff. We'll kind of partially start the workshop stuff and just see if we can get kind of some interactions going, clicking on stuff. So I'm just going to call this call it click shop for now, not a final name. I don't like that it doesn't keep the seamless. Interesting. I wonder if it can use renders other than OpenGL for the real game. Because ideally it would use other renders. Okay. Select. Oh, no. That's not what I wanted. Alright. Okay. No. Yes. Up a folder. Up a folder. Create folder. Click shop. Select folder. Alright. Click shop. Blah, blah, blah. Create and edit. Okay. So, I imagine we go 2D here. Alright, let's go just kind of find a tutorial here. Learn. Learn is always, whenever you always start a new language or framework, always go to their website. Good languages and frameworks and engines and whatnot will either have like a learn button or a get started button or something. And usually they'll have really good tutorials because how you get people to use stuff is teach people how to use it. So, let's see. So we're going to kind of jump around. So here we go. 2D tutorials, canvas layers. Alright, I'm going to kind of just skim speed read this for things I'm looking for, because I never read things all the way through anymore, because I'm too impatient. Alright, so canvas item is the base for all the nodes. Alright, so canvas item is kind of our base thing. Okay, so parallax. So right now I'm just kind of skimming for how to get stuff on screen and be able to click it. Okay, so here they basically have, yeah, so like your kind of asset tree. Okay, moving on, viewport. Oh, it's all that same thing. All right, viewport and canvas transformations. Okay, so they're kind of starting kind of low layer for an intro tutorial. Interesting. Here, let's try this actually. Your first 2D game. Alright, prereqs. Well, I start with 2D. 3D games are much more complex than 2D. It would be best if you stuck to 2D until you understood the game development process and how to use Godot. Well, arguable, but yeah. 3D math is complicated. Okay, step-by-step tutorial for beginners who followed the getting started. We did not follow the getting started. Let's go click getting started real quick. Step-by-step, scripting languages, creating your first script. Alright, project, create root node, other node, type scene, type sprite, in the search bar, blah, blah, blah. Okay, so adding a sprite, you can create sprite nodes automatically by dragging and dropping images on the viewport. That's always handy, so we'll want to create a couple images. Okay, so we can attach scripts to them. And then, allows you to select the language. Alright, so select the language, we open up. Hopefully I can use Writer, which I installed, but I didn't pin. So, just like WebStorm, the JetBrains product for web development is my favorite JavaScript and web editor. The Writer is their C# one, and that's my favorite editor for that as well. Alright, next, key maps. We'll stick with IntelliJ ones just because that's what I use most of the time. Alright, we need to install .NET. And I don't think I have to sit here and wait. And I want to install none of those. Alright, start using. Okay. So we'll get that going in the background. Okay, so alright, so this is a G-script, and this is nice too. Usually if you're working in something that has multiple languages, a lot of times they'll do this. so you can see your code in either way. So looks like here they use func as the function keyword, and then underscore int is our like main for the script, I guess, because it's not really a class. And then here they use a constructor inside the class. So standard C# stuff there. Okay, so it looks like they use var to declare keywords, just like we use let in JavaScript. And then, of course, in C# you have to use types, so int and float. Okay, all right. Member variables sit near the top. Okay. All right, all pretty standard stuff that if you've used one language, nothing in here that I've seen is going to really surprise you, which is actually the nice thing about coding. The more languages you've used, the more languages, or the easier it is to pick up new languages, because the more and more you'll notice the similarities between them. And so it's not really a matter of starting from scratch. You're just picking up the little bit of syntax differences. So it's not even, as much of a difference between English and Spanish. It's more like, English and English with a Boston accent. It's still most of the same language, just, a couple little things maybe are different. Okay, so got that. Let's go next. Listening to player input. Okay, so this is good to look at, because this is always one of the things that in engines kind of differs a good bit, but it looks like they're doing pretty much like we did with our input manager in our last two games in JavaScript. So it looks like they have this input thing, which would have been our input manager, and then we're checking is key action pressed. And then they have names here, and you'll notice UI left isn't a key, like a key you'll find on your keyboard, but this would be for a key mapping. So somewhere else they've mapped that this UI left will go to some button on your keyboard, or even on your controller, or, whatever you may be using. Okay. Moving when up is pressed. So, yeah, and this is pretty much exactly like we did with JavaScript. So, they're just applying things. Okay. So, can I actually play this? No, it's just a picture. Okay. Next. All right, using signals. They are messages that nodes emit. So this is basically events. Just like we added event listeners to our canvas and stuff, this is probably going to be just like that. Most languages and frameworks and stuff will have some kind of emitter or event system, or they're calling theirs signals. They're all kind of the same thing. Signals you also hear on like OS and stuff, like Linux calls things signals. Okay, so let's see. So search for button, type add. So blah blah blah. They add a button. They add a text. Okay, so they go node. They go signals. So it looks like they have a series of kind of event listeners here, or not event listeners. Actions that are triggered. So this is like where we do like click or key down or key up in JavaScript. This would be the equivalent to those, the event types. Okay, double click the press signal to open a node connection window. Okay, and then this would be our event handler. So they call that a receiver method. Good to know. All right, when connecting signals via the editor's node doc, you can use two modes. The simple one allows you to connect the nodes to have a script attached to them and create the node. The advanced view lets you connect to any node and any built-in function, add arguments to the callback. Oh, that's nifty. So you can, in the advanced mode, you can pass in parameters and stuff too. So that's kind of handy. I don't actually know. I don't remember if Unity let us do that or not. I think it did, but I don't remember for sure. JavaScript you can't really. Well, you can, but not directly. You have to bind a function. Okay, so, so yeah, so they create here, and then they just have some function that they're doing. Oh, actually, set process something. Not is processing. Oh, that's interesting. I didn't notice that on the other page. Hit the back handle. Oh, so instead of curly brackets, they're using colons. Oh, and if this is Python, like, it probably means tabbing is important. So you have to nest your text a certain amount into things instead of using curly brackets to indicate that this is part of it because it's tabbed in, and this now isn't, and this is a new statement. And then all of these are part of this function because they're tabbed in, and then if we add another line down here, it wouldn't be. Okay. So, moving right along. Alright, so function. So what is process? Before we need to simplify our process function to move the node automatically and not wait for user input. Okay, which we replace it with the following code, which we saw. Okay, so I think process. Okay, I missed that. Next to the process function. I think we missed that. Did they mention it? Nope. Mention it in here. Okay. To move process function, so I suspect process. Yeah. Calls it every frame. So this process is exactly like that tick function we implement in our JavaScript. And we don't need a draw function because Godot's doing the draw behind the scenes. So it's kind of neat to see how similar, pretty much we were kind of rolling our own in JavaScript and now we have, Godot in their language. It's neat to see all the similarities because they really are similar. If you can kind of figure out, if you know one thing and then you can kind of map that knowledge to another, to the bits that match up, it becomes real quick and easy to learn new things, which is one of the things I really love about programming. Once you kind of get programming down, there's not a whole lot you can't do anymore, so it's kind of cool. Okay, so where were we? Let's see, here. Okay, so basically then they made it so they hooked up this event to their on button press, and then they set process to not is processing, so they invert it. So if it wasn't processing, now it is. If it is processing, now it's not. And then they're using that to make their little character move automatically. So you hit the button, it starts moving. You hit the button again, it stops moving. So that's kind of neat. Alright, connecting a signal via code. You can connect signals via code instead of using the editor. So let's scroll down here. Okay, so here's basically, so this is pretty much the equivalent of us using add event listener on something. So they use connect instead of add event listener. And then this would be the event type, just like we do in JavaScript. This would be then the object that this function lives on. And interestingly here, they use strings for the function name. So instead of passing a reference to the function directly like we would in JavaScript or C#, in GD script, it looks like we pass them by string. So that's good to know too. Okay. And then, so the line reads like this. Oh, that's exactly what I just said. Okay. And then the visible property is a boolean that controls the visibility of our node. So it sounds like then basically they have a timer, yeah, and they even call it a blinking timer. So they have a timer that will make their character appear or not appear. Okay, so there's the full code right there. Okay, interestingly, one thing I don't see, so I guess it's just using some default value, is they didn't set how long the timer lives. Oh, I can see. They created a node for the timer and then got a hold of that node, which they did with get node, and then the name of the node. So, yeah, so we didn't do anything like this. Well, you could kind of argue that document.query selector is, but that's only for elements. This is more analog to, like Unity uses get component. So, if you're familiar with Unity, this get node would be the same as their get component. Okay, so cool. Custom signals. Okay, so we can create our own custom signals too, which is nice. So, looks like we use a emit signal. So we've not done this in any JavaScript things recently, but dispatch event is the equivalent in JavaScript for this. Okay, and then signal can optionally declare one or more arguments. Specify the argument names between the parentheses. Health changed, old value, new value. Oh, that's neat. The signal arguments show up. Okay, that's pretty cool. I like that. So basically, if you like say that it needs to have these two values, then in their editor it'll show those two values. So that's pretty nifty. And then you can emit the signal. Cool. I like that. Okay. Next. All right, we're on our first 2D game again. Cool. All right, so let's see. So prereqs. So we just did that. We speed ran getting started. If I'm an experienced programmer, you can find the complete demo source. All right, we'll pop that open, but we'll go through their thing still because that's neat to look at. All right, so new project. Okay. So, you know what? Why don't we follow along? I think it'll be interesting. So project, we'll quit our click shop. Okay, let's make a new project. What do they call this one? Dodge assets? I'm just calling it Dodge. We'll just call it Dodge. Names don't matter. I spend about 0.2 seconds trying to name things because you can always name, or at least naming projects, because you can always name them later. And you'll always think of a better name as you're working anyways, so don't stress about it too early. Alright, so no, create folder, Dodge. Okay, select. There we go. Alright, create and edit. Alright, now they have some handy dandy assets for us, so let's download those. Okay, so we got some art and a font. Alright, so let's just go ahead, extract all. Okay, I'm going to move these into here. And I'm sure we'll probably have to name those a certain way, but we'll put them there for now. Let's close these. And, okay, we'll leave that. We'll close this for now because we're going to use GDScript today. Okay, extract the archive and move the blah 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 into your project directory. Okay, so they want us to just move these directly. That DS store file isn't the file you need. That shows up when you zip. Mac, I think, is what does that. I think Linux does it. I think that's mostly a Mac thing. And yeah, the screenshots look pretty Mac-esque, so. Okay, okay, so we got that now, yay. Okay, oh, that's nifty. It's a little icon there, which means I bet you can replace it and get whatever you want to show up. Okay. Alright, the game is designed for portrait mode, so we need to adjust the size of the game window. Alright, Alright, so project settings, window, okay. And they want us to make it 480 by 720. Alright, easy peasy. 720, okay. And normally when you build a game, you wouldn't hard code a width and height. You'd want to design it in such a way that things can fill the space. And how you do that differs on a game. Like a 3D game, you pretty much just need to kind of change your camera's window. And so, like, if you have a really wide screen, you might see more stuff than if you have, like, a standard screen. And then mobile's kind of the same way because, you know, not all phones are the same. If you're doing, like, UI, you'll usually do what's called docking a element to a certain part of the screen. So, like, you may dock it to, like, the top left corner or the bottom right corner. And so if the screen gets bigger, they move apart or separate. Or you may do it based on width or whatever. But to keep it simple, as I'm sure they are here. Oh, and there's even a resizable right there. I should read the next line. So there's the resizable. So we'll see if they actually do that or if they don't, just to keep things simple. Okay, scroll down to the bottom. Under stretch, set mode to 2D and aspect to keep. Okay, so mode to 2D. Aspect to keep. Okay. And so that would be the aspect ratio. So that would mean, like, in this case, so let's see, 480 by 720 is a really weird ratio, if I'm not crazy. No, is that 9/16 maybe? No, or 10/16. It's almost kind of 10/16, but not really. Actually, is it 4/3? Yeah. Yeah, it's a weird aspect ratio. It's much more square than your monitor will be. So, but we're gonna apparently keep that, which usually means it would, if you're using a different size, it means it would it'd stretch. I assume that's 2D will stretch, but it'd probably like put some black bars to indicate that you know, to not let it shrink. Just like if you watch, you don't see any more of that now that we all have, wired screens. But you might sometimes see a movie that was recorded at an aspect ratio that doesn't quite fit your TV, so you made black bars on top or on the side. Same deal with if we're using keep here. Okay. In this project, you'll make 3 independent scenes: player, mob, and HUD, which we will combine into the game's main scene. Oh, okay, so that's interesting. That's different from Unity. So, sounds like we can actually combine multiple scenes into one. That's kind of neat. Okay. A large project, it might be useful to create folders to hold the various scenes and their scripts, but for this relatively small game, you can save your scenes and scripts in the project's root folder identified by res. So res, probably short for resource, is kind of our root folder. So that's good to know too. You can see your project. That's actually a nice way to handle that, just to create a protocol to put at the beginning. So that way if you need to refer to the absolute path. So I like that. That's nicer than how Unity does it. Okay, creating the player scene. Alright, the first scene we'll define is the player. Or the first scene we will define. First scene will define the player object. Okay. Alright, one of the benefits of creating a separate player scene is that we can test it separately even before we've created. That's pretty handy. Okay, so. Alright, to begin, we should choose a root node for the player object. Alright, have we created the scene? I don't think. They just kind of made a player node. Okay, so. Alright, close that. Let's see. So we'll add a new. Okay, so I guess scene and node are kind of interchangeable. Interesting. Alright, general rule of scene's root node should reflect the object's desired functionality, what it is. Click other and add an area 2D. Alright, so other node. Search area 2D. Oh, there it went. Alrighty. Create. Oh, thanks for following me. I totally forgot that noise. It scared me. Let's turn down the volume just a bit. The volume on my computer. You guys just couldn't hear that, but it's... Well, actually, maybe you could through my mic. It's cranked up a bit. Alright. So, we created a new area. Let's see, what do we got? Actually, let's do this. Hit Windows key left and Windows key right. So now I can have them both up at the same time. Alright, so what we got going on here? Alright, so we made our 2D node. Got to display a warning icon next to the node in the scene tree. You can ignore it for now. Okay, will do. I always ignore warnings. Alright, with Area 2D, we can detect objects that overlap or run into the player. So that's cool. So Area 2D can handle collision then. Change the node's name to player. So let's see, right click, rename. Ah, nice. F2. That's the same one that like Windows Explorer uses. So I always like when that's the shortcut to rename, because that's what I always try. Alright, player. Alright. Oh, or I guess we can double click it. Yes, okay, but I like F2. Alright, we can add additional nodes to give it more functionality. Before we add any children to the player node, we want to make sure we don't accidentally move or resize them by clicking on them. Select the node and click the icon to the right of the lock. Its tooltip says make sure the object's children are not selectable. Okay, so click that. And I think it's this one. Make sure, yep, okay. Alright. Save the scene, Control S. Alright, and we'll save it. Do they care what we save it as? Not really. Okay, we're going to name it player, which it already is. Nice. Alright, so there we go. Alright, yeah, I really like this multi-scene thing. That's interesting. That's different than Unity. And I can see some nice usage for that. That's cool. Excited. Alright. Alright, for this project, we'll follow the Godot naming conventions. Okay, so they have two different ones. So let's read the C# first, just because I know what those typically are. Classes export variables and methods will be Pascal case. Private fields use underscore. Don't love that, but that's pretty standard. Local variables and parameters use regular camel case. Be careful. Okay. So yeah, so that's pretty standard C#, which you would see in other things. So that's pretty standard. All right, GD script. Classes, which nodes use Pascal case. Variables and functions use snake case. All right, so that's different than I usually use. I usually use camel case, so I'll stick with snake case. And constants use all caps, and that is what I usually do. So that's good. Oh, there's a style guide. I'll check that out later too. Okay, sprite animation. Click on the player node and add an animated sprite node as a child. Okay, so add child node. And we want a animated sprite. All right. That will handle the appearance and animations for players. Notice that there's a warning simple. We're ignoring that too. Alright, animation sprite requires a sprite frames resource, which is a list of the animations it can display. To create a new one, find the frames property in the inspector. Okay, so frames right here. Click empty, new sprite frames. Okay, click again to open the sprite frames panel. Okay, so there's our panel. On the left is a list of animations. Click the default one, okay, and rename it to walk. All right, walk. All right. Then click the new animation button to create a second animation named up. All right. F2, nope, F2 did there. Up, all right. Okay. Where was I? Up, okay. Find the player images in the File System tab. They're in the art folder. Okay, and actually, let's go ahead. Let's pop in here and we'll just see what art we have. Right-click, View, Extra Large Icons. Okay. Alright, okay. So that's what our enemies look like. Here's our player. Okay, so pretty simple. I think a real game, you'd probably have more than 4 frames for the entire character, but maybe you're minimalist. Maybe you're making a 4-frame game. Nothing wrong with that. Apparently we are. Alright. So we go to walk. Alright. Then click new animate. Oh, we did that. File system. Okay, we want to be on up. No, we do want to be on walk. Okay. And we'll drag the 2 images over. For each. Named blah 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 blah. Okay, so art. Alright. So player walk 1. Player walk 2, up, player up 1, player up 2. Oh, look, he's there. He's kind of cute. Alright. The player images are a bit too large for the game window, so we need to scale them down. Click the animated sprite node and set the scale to 0.5 to 0.5. So we're chopping them in half. Or shrinking them in half, I guess. Not speed scale. Where is this supposed to be? Click the animated sprite node and set the scale property. Am I blind? I'm not seeing a scale property here. I see a speed scale, but that would be how fast it moves. Transform. Ah, there we go. It's hidden in the transforms. 0.5. Okay, there we go. It says transform there. It just doesn't in the text. Okay. Finally, add a collision shape 2D as a child of player. Alright. So yeah, usually in games you'll have a separate collision. So I kind of touched on this last time with the space shooter, how like we were using a box collision to manage our thing, and really we'd want a better shape. So an approach you'll take a lot is to have some kind of collision shape, which is kind of a simplified shape for your player, and so or your whatever. So instead of checking like all the pixels of like a highly detailed character, you'll like maybe have like a circle and a square, or a circle and a circle, or in this case it looks like we're going with a stretched circle, so like an oval or a capsule, I guess. Okay, so we're going to do a collision shape 2D. And it looks like they have 2 different versions here. A collision polygon, so that'd be straight edges, and then a shape, which I guess is more generic. Let's find out, because that's what we're making. Okay, this will determine the player's hitbox. Alright, or the bounds of the collision. For this character, a capsule shape 2D node gives the best fit. So shape, new capsule shape 2D. Okay. Using the two size handles, resize it. Alright, so I'm using my scroll wheel to zoom in. Yay, middle mouse button is move. That's kind of standard stuff. I always like when things use standard conventions because it makes it easier to not read documentation. You can just kind of guess and it works. Alright, so fit it nice and tight. There we go. His little feet have some immunity, but otherwise he's good to go. Alright, cool. Alright, when you finish your player, scene should look like that. We look at, oh look, the warnings went away. Alright, make sure to save the scene again, always important. Control S. Alright, and let's hit next. Alright, cool. Alright, coding the player. In this lesson, we're going to add the player movement and set up its collision detection. Alright, so to do this, we're going to add a script. So we're going to hit the little script button. Alright, whoops, hang on. Do we need to be, yes, it looks like we need to be on player, so the script gets attached to the player. Okay, in the script settings, if you're creating C# or other, select the language act. We're sticking with GD script for now. Alright, so player GD, that's good. Okay, so we'll hit create. Alright, here we go with the editor. Let's see, are we able to shrink these? Are we able to collapse them entirely? Okay, so we can shrink a bit. Doesn't look like we can completely collapse them. We could change the dock position, but I actually like the position. What's this one do? No, we do not want that. Oh, that's kind of neat actually though. Okay. Alright, that's not too bad. Oh, here, what does this button do? Ah, nice. This way we can go have lots of room for text, which I don't think we need right now, but it's always good to know that we can. Okay, cool. Yeah, I'm already a fan of Godot. It's pretty well thought out. I like it. Alright, start by declaring the member variables this object will need. Okay, so we extends, so looks like extends and then whatever is our, how we extend something, and since we made an area 2D, we're extending it 2D. Okay, so we're going to declare some variables up here. Export var speed equals 400. So I'm getting no semicolon. That's going to drive me nuts. Are semicolons optional? I will probably put semicolons on all the lines on accident. We'll see if I break that out. I'm guessing export var probably means is basically a public variable that other things will be able to see, and then regular var is probably private. But that's just a guess. Okay, we're not initializing that. All right. Oh. This tutorial keeps reading my mind. Alright, using the export keyword on blah 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 allows us to set its value. Oh, okay. So, I'm kind of right, but not really. It's to set its value in the inspector. So that would mean if we hit this... Ah, neat. So, it's right there. I like that better than... Unity has a similar thing, but theirs is kind of like the default, and you have to go out of your way to make them not show up here. So I kind of like that you have to explicitly specify it like that. Okay, the standard for values, yes it is. Alright, click on the player node and you'll see the property now appears in the script variables. Script variables. Oh. That's exactly what I did. Alright, maybe if I read like 2 lines further before I go into explanations, we'd see that the tutorial's about to explain it. Alright. The ready function is called when a node enters the scene tree, which is a good time to find the size of the game screen. Okay, so ready's kind of their on start. Alright, I guess pass must just be a like, I'm a function, but I'm not doing anything, ignore me. Screen size equals get viewport rect.size. Okay, so viewport is the area we're seeing. That's a pretty standard name. Okay, now we can use the process function. So this was our equivalent to tick. To define what the player will do. Process is called every frame, so we'll use it to update elements of our game, which we expect will change often. For the player, we need to do the following. Check for input, move in the given direction, play the appropriate animation. Alright. So first we need to check for input. Is the player pressing a key? For this game, we have 4 direction inputs to check. Input actions are defined in the project settings under input map. So let's go look at those. Input map here. Okay, so, and here's where I was mentioning that there's probably keybinds, so they have multiple things assigned to each of these, which is cool. Okay, And like this, yeah, nice. They even have controllers set up by default. That's neat. We may be able to use our controller right out of the box. Okay, so we're going to add a button to, we're going to add, click the add button to add the move right action. Okay, so move right, add. Okay, and then we're going to assign a key. And that's interesting. They have physical key versus just key, which must mean it probably includes virtual keys as well. Like if you had like an on-screen keyboard, like you might have on, well, on a tablet you wouldn't quite use it, but you know, you have virtual keyboards on computers sometimes too, and you could potentially use it for that. So that's kind of neat. Okay, we're going to do, okay, so just press any key. So I'm going to press the right arrow key. All right. And then, so we're going to repeat that for the other directions. So move left, key, left, oops, nope, left, move up, key, up, move down, add, key, down. Okay, neat. Alright, your input map should look like that. They look good. Click the close button. Alright. We only mapped one key, but you can map multi-joystick, blah, blah, blah. Okay. So now, let's make a process function. I'm just going to delete this extra gobbledygook out. Okay, we'll leave that comment. Okay, so func process delta. They even use delta, so just like we did with our JavaScript where you had the delta of time, they have the delta of time. Alright, velocity equals vector 2.0. So the player's movement vector. And so vector is either just it's some number of values indicating space. So in this case, we have a vector 2, which means we have two values, an x and a y. And then 0 just, it's set to 0. So in ours, we used for the ball's movement, if you remember, we used an angle and a speed, and then we did the math to figure out the vector. We broke it into x and y, basically. I mentioned then that there's another way you can do it where you track the x and y separately. That's basically what we're doing here. We're just tracking it in one thing called vector, a vector 2. Okay, so if input dot is action pressed move right, oh no, this is needed. All right, velocity dot x plus equals 1. If input dot is action pressed move left, velocity dot x minus equals 1. If input dot is action pressed move up, move down, velocity dot y plus equals 1. If input dot is action pressed move up, velocity dot y minus equals 1. All right. Then we're gonna have, oh, I just noticed in their editor they kind of show these marks so you can know you're tabbed over it far enough. That's nice. Velocity dot length greater than 0. Velocity equals velocity. Okay, cool. I was wondering about that. Animation sprite dot play. Else animation sprite dot stop. Okay. Alright, so this normalized bit here, and let's see, they probably explain it. We'll read through. Okay, which means we said, yeah. Okay, yeah, so basically what they're doing, so if you remember when we did the ball, we mentioned that we have a speed and we want it to always move that speed, so we track the angle and stuff. So here, what we're doing is if like, say you're holding right and down, you're going to be moving one to the right and one down, which actually means the total distance you're moving, that diagonal, will be a little bit more than one total, which would mean you're actually moving faster than the speed we want to let you. So you'd actually be moving faster going down and right than you would going the other directions, which you usually don't want. So they have a nice little handy normalize function here, which basically makes it so both of those end up being a value that when we multiply both of those with the speed, we'll end up with exactly 400. So that's pretty handy. Yeah, it ends up with a length of 1, which doesn't actually mean that x and y are going to be 0.5. They're going to end up, like 0.7 something, I think. Which, when you pop them in cosine and sine, end up adding up to 1. So cool. So that's a nifty little easy way to handle that. That's real nice. Okay, and then they multiply it by speed. Cool. All right. If you've never used vector math, yeah, there's a vector math link here. If you've not, I would check it out. Vector math is usually something I don't think you learn until, I don't know, probably linear algebra, which I think most people don't get to until either very late in their high school career, and like that's only if you're like doing advanced math or college usually. So it's not super complicated. It's like trig with extra steps. Basically, it uses a lot of stuff you'll learn in trig. But yeah, it's good to read up on it. 3D vector math is a pain. So that's why we're sticking with 2D for now. Alright. We also check whether the player is moving so we can call play or stop on the animation sprite. So I guess that will just move us. So, alright, so, interesting. So $sign is shorthand for get node. In the code above, $sign animated sprite. Oh, I see. So, $sign animated sprite is getting our animated sprite. Neat. I like that. That's really cool. That's a good idea. Alright, returns the node at the relative path from the current node, or returns null if the node is not found. Since the animated sprite is a child of current node, we can use $sign animated sprite. Neat. I like that. Alright, now that we have a movement direction, we can update the player's position. We can also use clamp to prevent it from leaving the screen. Hey, look, we implemented a clamp on ours. I love seeing, similar things. It means I kind of know what I'm talking about. That's always exciting to know. Alright, clamping value means restricting it to a given range. Add the following to the bottom of process function. Make sure it's not indented under the else. Okay, so we'll type that out. It's always good when you're working with tutorials to actually, instead of, we could just copy-paste this code, but it's good to always type it out because that's how you learn. If you just kind of copy-paste everything, you're not really going to remember anything. If you have to use the brain power to, actually translate what you're reading into, tell your fingers what to do and translate that and actually read it to make sure you don't have typos and stuff, it makes it a lot easier to learn. So always type code even when you're following a tutorial. Let's just see if we can shrink that. Okay, it's kind of cutting off. Can I? No. Okay. Oh, that's kind of neat. I kind of like that. It kind of shows you the overall shape of your code so you can kind of jump to it real quick. That's neato. Okay. Alright, now that we have clamp. So we're just clamping it so it stays within the bounds. Interestingly, I wonder if this is automatically taking into account the width of the character. Because in our code, we had to subtract the width of the character to make sure it stayed on. So I wonder if this automatically has that code in it to check the width of it. It probably does. We can find out in a sec. And then here also they use the delta parameter. I'm going to separate those to apply it just like we did. So, and let's see, delta parameter first to the frame length, the amount of time that the previous using this value. Okay, they don't specify if it's milliseconds or seconds or frames or what. So it'd be interesting to know, but it doesn't really matter as long as the thing we're multiplying with does the math right. So. Alright, if you ever get this error, attempt to call, likely means you spelled the node name wrong. Okay, choosing animations. Okay, let's go ahead and play. Alright, so F6 is our shortcut to play, but we'll hit play. No main scene selected. Select current should work. Alright, oh cool, pops up a little thing. Alright, there's a little dude, and he's not doing a whole lot. Okay. keyboard's not working. He's kind of smushed in the corner. So let's take a look real quick and make sure we got things right. Alright, so function, process, delta. Actually, let's check the other bit first. Alright, so screen size, viewport rect size. Okay, so that should be good. Okay, process. Set it to 0 if... I'm going to put a space there because I like spaces between clumps of things. Okay, so if we're right, velocity +1, -1, +1, -1, x, x, y, y, right, left, down, up, okay. Velocity length is greater than 0, velocity equals velocity dot normalized times speed, animated sprite dot play, else animate sprite, okay. So, position plus equal velocity times delta. Oh, and here, just to point out too, so this is actually doing vector math. We wouldn't be able to use this in just plain JavaScript. We'd have to add each value directly, but they're able to do it in one because they're using a vector too. So one of the handy things about it. And then clamping, we have position.x 0, screen size.x. Okay, I don't see anything, so I'm going to comment this out real quick, just because I'm curious. Oh wait, hang on. I didn't even notice this down here. Attempt to call function stop and base null instance. Is that call play? We got call stop. Same deal, I guess. So did I typo something? Oh, yep. So what did they call this? Oh, yeah. So they put this warning here. I'm like, I won't need that warning, and then I needed that warning. All right, animated sprite. There we go. Now it matches. Oh, I just noticed this autocomplete, it looks like, so we're going to trust the autocomplete from now on. Alright, I'll hit restart, load her up. Alright, hey, there we go. Oh, look, he moves, that's so cute. Okay, so interestingly, the bit I was wondering about doesn't actually work. So, there isn't anything in clamp that takes care of that. So we would have to add a bit of padding to that 0 in the screen X here to make sure that he ends up staying fully on screen. So it looks like their origin point is the middle. So that means position is actually the middle point of him. So let's just try. I bet it's probably something like animated sprite dot. Okay, it may not be as simple as that. Okay. Okay. Interesting. We'll have to figure out how to get the width and height of things later. Okay. So, choosing animations. Now that the player can move, we need to change which animation the animated sprite is playing based on its direction. We have the walk animation, which shows the player walking to the right. This animation should be flipped horizontally using the flip H property for left movement. We also have the up animation, which should be flipped vertically with flip V for downward movement. Okay, so they're just using mirrored sprites to do it. That's one way to do it. You can also have separate sprites for each, obviously. And which you use really depends on the design of your character. Like, with a character this simple, we're not going to be able to tell if we've mirrored it or not, because he's basically symmetrical, so he looks right both ways. If you have, like, say you had a character with, like, something in their hair or something, if you mirror that, the thing in their hair is going to be on the wrong side, and that may be okay. And in fact, like a lot of Super Nintendo era games did that and they didn't care. And even some modern games will do that and not care. But if you do care, you'd need separate graphics for each, so you don't notice that the thing in your hair or like a sword on their belt or something is that flip-flopping back and forth. Alright, but we are going to flip. Alright, so we're just going to keep adding more here. So if velocity.x not equals 0, alright, animated sprite.animation equals walk, animated sprite.flip v equals false, animated sprite.flip h equals velocity.x less than 0. Okay, so if we're moving in the x direction, we're going to use walk. We'll never have vertical flipped for walking, and we may have this depending if we're moving to left or right. Alright? Okay, so their else if is one word, elif. which you can just read else if. So else if velocity.y is not equals 0, animated sprite.animation equals up, animated sprite.flip v equals velocity.y greater than 0. Okay, so and this case means too, since the y bit is an elif, that means if we're moving up and down at the same time, or some combination, whatever it may be, we're always going to use the walk animation, which is left to right animation. And then if we're only moving up and down, that's when we're going to use the up or down animation. Which again, that's one way to do it. If you were being more fancy, you might have an 8-direction character who has like a specific animation for moving at diagonals, or you may stick like this. It's it really is up to you and your art sensibilities. Okay, so the Boolean assignment in the code is common shorthand. Yeah, so basically this just resolves to either true or false. Okay, play the scene again. Let's take a peek. Alright, so he's swimming. Alright, so moving left, moving right. Nice. See his eye changing back and forth. Then up, down. Okay. Neat. Okay, cool. Alright, when you're sure the movement is working correctly, add this line to ready so the player will be hidden when game starts. We'll add hide. Okay. So, for some reason we're hiding the player. I'm sure we'll find out why. Alright. Preparing for collisions. We want player to detect when it's hit by an enemy, but we haven't made any enemies yet. That's okay, because we're going to use Godot signal functionality to make it work. Add the following at the top of the script. After extends area 2. Okay, so we're defining a custom signal, which I really like that approach for dealing with interactions. That's really cool. Alright, this defines a custom signal hit that we will have our player emit when it climbs. We will use area 2D to detect the collision. Select the player node and click the node tab next to the inspector tab. Okay. And to see a list of signals, and there's our custom one, Neato. Alright, notice our custom hit signal is there as well, since our enemies are going to be rigid body 2D nodes, which rigid body just basically means it's a body that's rigid. Use it for like physics-based collisions, or just any collisions. Let's see, pardon me, I talk too much. Alright, signal would be Alright, we want the body entered signal. So we're going to use body entered. This signal would be emitted when a body contacts the player. Click connect, and the connect a signal window appears. So click connect, okay. And then when I click the connect and connect signal, we don't need to change any of these settings, so click connect again. Okay. Oh, nice. It just added that function for us. Neat. Alright. Note the green icon indicating that a signal is connected to this function. That's handy. Alright, add this code. Alright, so I'm going to hide. So the player disappears. I think he dies from one hit. Oh no. Alright, and then we would emit a signal hit, so we'll emit the custom signal. Okay, and then must be deferred as we can't change physics properties on a physics callback. Okay. Collision shape 2D, hit enter for the autocomplete so I don't misspell it and we have a weird error that makes me look bad. Deferred, disable, true. Okay, not sure what that does yet. Let's see if they say. Each time an enemy hits the player, the signal is going to be emitted. We need to disable the player's collision so that we don't trigger. Okay, so we're just turning it off so we only trigger it once. That makes sense. Alright. Disabling the area's collision shape can cause an error if it happens in the middle of the engine's collision processing. Use set deferred tells Godot to wait to disable the shape until it's safe to do so. Okay, so that makes sense. So basically, since they're handling this for us, if we change it midway through handling that, it could cause something weird to happen because they're not ready for it to change at that point. So we're basically saying, change this. We're saying we want to set disabled to true, but wait until it's safe to do so. So that makes sense. Okay. The last piece is to add a function we can call to reset the player when starting a new game. So, I guess we'll just put it at the bottom. Func start, And interestingly, no underscore, so we're probably making this public. Okay. Position equals pause. Okay, yeah. Show collision shape 2D dot disabled equals false. Okay, so this is just restarting it. So we set the position to some starting position, we show it, and then we make it not disabled. Alright. Neat. Alright, I'm going to hit Control S, even though it doesn't tell me to, because Control S is a good idea. Alright, creating the enemy. Now it's time to make the enemy. Our player will have to dodge. Their behavior will not be very complex. Mobs will spawn randomly at the edge of the screen, choose a random direction to move in a straight line. This is very similar to our space shooter, except it sounds like we're not shooting them, we're just dodging them. Okay, we'll create a mob scene, which we can then instance to create any number. Okay, I can't get over how much I like this this use of scene as kind of a overall thing. It's kind of a different term than scenes usually used, because scenes usually used like for the whole everything on the screen. But this is a really clever way to do that, and it makes me happy. Alright, so we're gonna click scene, new scene. Wait, hang on. Scene, new scene. Okay. And the following nodes. Okay, so they're just want us to dump all of these in there. So I guess this is the root. So we want a rigid body 2D, this guy. Alright. Create. Now we'll rename that to mob. Then we're going to add a animated sprite. We're going to add a collision shape 2D. We're going to add a visibility notifier. That's new. Not sure what that is. Okay. So we go. Don't forget to set the children so they can't be selected. Ah, good call. I will have to remember to do that. Alright, save that. Wait, hang on. Am I editing? I want this to go away. Well, let's call that mob, so that's apparently the scene. How do I get out of coding view? Oh, here, I see. So the script will hit 2D. There we go. Okay, and now I click mob, and I click this guy to lock its children, which is a good idea because all the children should be relative to the mob. So like when I move this, I always intend to move mob. I don't want to move like the collision shape 2D. So that's handy to remember to use that. Okay. So, don't forget, like we did. Okay, in the rigid body 2D properties, we're going to set the gravity scale to 0. Okay. So, yeah, so this rigid body is for physicsy things. See, it has a mass and a weight and stuff, so it can calculate physics things, but we're going to set it to gravity to 0, so it won't fall. We can set to negative gravity and have it fly. Okay, so we set it to 0, so it's just not affected by gravity. Okay, and look at that, they say it in 2 words I didn't read. Alright, in addition, under the collision object 2D section, click the mask property. Okay, so collision... Wait, was I supposed to do a collision? Oh, no. We're still under rigid. Okay, collision object. Under the collision object 2D, click mask. Okay. And uncheck the first box. This will ensure the mobs do not collide with each other. Oh, interesting. Huh. So they must use... to learn more about that later, but it seems like masks are... We can use those to, I guess if it's on, it would collide with itself. If it's off, it can't collide with, or not itself, but others of its type. Interesting, okay. Alright, set up the animation sprite like we did for the player. This time we have 3 animations, fly, swim, and walk. There are 2 images for each. Adjust the speed FPS to 3 for all animations. Okay, so, animation sprite. And then there, frames, new sprite frame, click it, okay. Now we have, alright, so we're going to we'll just rename this one to fly, name this one to walk, this one to swim, alright, and then we just will tweak these all, oops, 3, 3, 3, 3, Okay. Now, let's see. Alright, so let's start at fly. So fly, 1, 2, swim, 1, 2, walk, 1, 2. Alright. Set the plane property in the inspector to on. Alright, so where is that? So I think the inspector's over here. Down here, I see a loop. Is it a mob, maybe? Plane. We're looking for plane. So the plane property in the inspector to on. This is the inspector. I would imagine it's in here. Visibility, material. Pause mode, process, script. Oh, there, plane on. There we go. Okay, swimming. And we'll scale it to 75, 75. Alright. And that was in transform. Scale. 0.75, 0.75. Okay. As in the player scene, add a capsule shape 2D for the collision. New capsule shape. Alright. And you'll need to set the rotation degrees. 90. Alright. And then there. Let's do this one first. Alright, get it that way. Okay. And then I'm gonna use my arrow keys, move it over a bit. Okay, we'll leave it like that. We'll let its little fins be non-hittable places. Okay. Okay, save the scene. Alright. Add a script to mob. Alright, click mob, create. Okay. Extend this body. I'm just gonna blank this out. Okay, so we're going to do animated sprite.plane is true. Interesting. I wonder if that bit's actually needed since we turned on the plane thing. I think that would be the same thing. Alright, get animation names. Alright, so we're getting an array of animation names. And animated sprite dot animation. Okay, so alright, so rand I, that's nifty. That would be for random integer, I imagine. Mod mob types dot size. So basically we're going to make it so each of them will randomly do one of the animations. Okay. And look at that. It just explained all the words I just said. Alright. Neato. Oh, that is neat. It automatically does -1, so we can just do size there. That's handy. Alright, you must use randomize if you want your sequence of random numbers to be different every time you run. We're going to use randomize in our main scene, so we won't need it here. So randomize would be their seed function. So when you do random stuff on a computer, it's not actually random. It's usually based on something, some seed value. Common seed value to use is the current time, because time's always different. And if you use the millisecond time, then it's pretty wide number of ranges, because in 1 second that's 1,000 different possible numbers, so it's really hard to get the same exact sequence of random numbers. But if you do seed random number with the same thing, like say we use 100 as a random seed, doesn't matter if we're all using the same random algorithm, we'll all get exactly the same number. If you've ever seen that Doctor Who episode with the pyramid and stuff, and they all start saying the numbers, that's exactly what happened. That's actually what they're talking about. I actually love that episode just because it's so programmery. Because if you use the same seed value, every random number is exactly the same. So what randomize does would be to seed the value, and I don't know how it seeds it. It probably will seed it with time, because that's pretty common. But it sounds like we have to call that to actually properly seed our thing. So probably they seed with 0 unless you call randomize or something like that. Okay, alright, the last piece is to make the mobs delete themselves when they leave the scene. So this, just like we did with our bullets and enemies, we're gonna, when they get off screen, we're going to make them go away. And it looks like on here, there's already a, oh, that's what the visibility notifier 2D was for. It gives us actions for when they disappear. We'll just call it Q free, which I guess gets rid of them. Neat. It's a lot easier than the code we had to do to clean up. Alright. So, we'll make enemies spawn randomly around the game board and move forward. Okay, so let's go forward. Alright, so the main scene time. Control S. Okay, we're all set. Now it's time to bring everything together. Create a new scene. New scene. Alright, 2D. Okay. Create a new scene and add a node called main. The reason we are using node instead of node 2D is because this node will be a container for handling game logic. It does not require 2D functionality, so that makes sense. So we'll do other node, just node. Wait, where's just regular node? There it is, node. The vanilla-est of possible things you can make it, basically. Alright, the reason we are using node instead of node 2D is because this node will be a container for, okay, I read that. Click the instance button, represented by the chain, and select your saved player scene. Okay, open. So it added a whole player scene. That's nifty. Alright, now add the following nodes as children of main, and name them as shown. Alright, so we're gonna add a timer. Does this add new? Yeah. Okay, so timer. We'll name that mob timer. Another timer. Oops, I added that to mob. Need to add that to node. Alright. Name that a score timer. Node first, there we go. Alright, another timer. Name it start timer. Start timer. Okay, and a position 2D. Oops. Position 2D, which we'll name start position. Okay. Set the wait time property of each of the timers to the following. So 0.5 for mob, 1 for score, and 2 for start. Okay. In addition, set the one-shot property of start timer to on. Okay. And set the position of the start position to 240 by 450, which is almost in the middle of the screen, but not quite. Okay. Alright, so I'm guessing this is probably the timer to control when mobs spawn. This is, we'll probably get points every second we survive. And then this is probably like a countdown in the beginning until the game actually starts, from the time it loads to the time it actually starts doing stuff. Okay. Let's see if I'm right. It wasn't the line immediately after. I'm shattered now. Alright. We'll be spawning. We want them to appear at a random location on the edge of the screen. Add a path 2D node named mob path as a child to the main. Oh, I didn't rename this. Main. Okay, we're adding a path 2D. Alright. When you select the path 2D, you will see a new set of buttons. Let's zoom out so we can see our window. Okay. I think the blue outline is the width and height that we specified, which actually means we can move our player down here. Okay, so path. Okay, there's our new buttons. Alright. You select the middle one, add point. That one, okay. And draw the path by clicking to add the points at the corners shown. To have the point snap to grid, make sure use grid snap and use snap are both selected. These options can be found to the left of the lock button. Alright, so snap. So, grid snap, and it says, I don't see a use snap, I just see use smart snap, probably that one. Toggle smart snapping. Okay. I know they actually do have another one that I don't have, maybe because we're squished. Let's expand. Yeah. they've tweaked it in a recent version. I don't know. Okay. Anyways, okay. Draw the path. Alright, important. Draw the path clockwise order, or mobs will spawn pointing outwards. Okay. Good to know. Alright, so we're just gonna, we're gonna trace our blue box. So, click, click, click. Okay, I guess I'm done. Did I only click 3 times? I only clicked 4. Click. Alright, I think we're good. No, they didn't have to click 4 times. We did. But, okay. To placing point 4 in the image, click the close curve. Okay. I think it did that automatically for us. Okay. Now that the path is defined, add a path follow 2D node. Why did we need this? Mob path. And add a path follow 2D. Call it mob spawn location. Okay. This node will automatically rotate and follow the path as it moves, so we can use it to select a random position and direction along the path. That's pretty handy. Alright, scene should look like that. I think we're good. Alright, main script. Add a script to main. Alright. Create. At the top of the script, we used export packed scene to allow us to choose the mob scene we want to instance. Okay. So, export packed scene there mob scene. And make it there score, not scare. Okay. Func ready. Randomize. So there's a seeding it. Okay. Alright, click the main node and you will see the mob scene property in the inspector under script variables. Okay. Okay. So here's where, so we can either drag or we can hit load. We'll just drag from here. Mob. Drag from the file system doc onto the mob scene property. Drag it. Oh, wait, that's not the scene. That's the scene. There we go. Okay, nifty. Alright, next select the player node. Okay, and access the node doc on the sidebar. Node doc. Oh, this thing. Okay. Make sure to have the Signals tab selected in the node doc. Signals tab. Okay, we're on Signals. You should see a list of the signals for the player node. Find and double-click the hit signal in the list. This will open the signal collection dialog when we want to make a new function named Game Over. Alright, so double-click. Make a new function called Game Over. And do we want it? We want okay, and it does look like it goes on main. Okay. Then we do game over. Score timer dot stop. Mob timer dot stop. I'm gonna make a new game function. Score equals 0. Player dot start. Start position dot position. And start timer dot start. I like their use of the start position here because then that means you can control it with your UI and kind of visually. So I imagine so if I click on this, it actually shows me where it's going to start. So that's handy because then I can like move and it's like, oh, I want my player to start here. So you can kind of use the visual to finesse the kind of nice details, and then you don't have to rerun it over and over again to see it. Because you could just kind of finesse it visually. So that's always handy. So that's a clever way to do that. Okay, start timer dot start. Okay, cool. Now connect the timeout signal of each of the timer nodes to the main script. Start timer will start the other 2 timers. Score timer will increment the score by 1. Okay, so func on score timer timeout. Score plus equals 1. Okay, and func on start timer timeout. Mob timer dot start. Score timer dot start. Okay. And on mob timer timeout, we will create a mob instance, pick a random starting location along the path 2D and set the mob in motion. The path follow 2D node will automatically rotate as it follows the path, so we will use that to select the mob's direction as well as its position. When we spawn a mob, we'll pick a random value between 150 and 250 for how fast each mob will move. So they'll move at varying speeds between those two. This is a lot like our space shooter minus the shooting, and they're coming from all directions. So that's always cool. Maybe future stream will re-implement our space shooter in Godot. That would be fun. I think maybe that'll be our next learn stream. All right, note that a new instance must be added to the scene using add child. Okay, so func on mob timer timeout var mob equals mob scene.instance var mob spawn location equals get node mob path by. Okay, so let's see. How do we? Okay, so that's getting this guy inside of mob path. Okay, so we have to use this instead of the $sign, I guess, because it's nested down. That makes sense. Okay, mob spawn location dot outset equals rand I. All right. All right. Here direction equals mob spawn location dot rotation plus pi divided by 2. Okay. So mob spawn location dot rotation plus pi divided by 2. Okay, so basically they're getting the rotation, then it's turning it 90 degrees in, so it's facing inward from where it would have been if it was following the path. That makes sense. All right. Mob.position equals mob spawn location dot position. Okay, so we figured out the location. We just set the new mob to it. Okay. Direction plus equals rand range, so get a random number in a range. Negative pi divided by 4, pi divided by 4. And they're using radians for the degrees, which is pretty common in computer programming. Just because, like, in trig, that's what trig functions expect. They expect radians and stuff. So some languages will have you use angles and then convert them behind the scenes, but most don't. So this one, it looks like they don't. So, let's see. So 2 pi is 3, 6. So it's easy to kind of work out kind of the relative angle. So 2 pi is 1 circle. So 1 pi is half a circle. So, which is 1. So 2 pi is 360, full circle. 1 pi is 180, so half a circle. So half pi is a quarter of a circle, so 90 degrees. So 4 pi would be 45 degrees. So we're shifting their direction by 45 degrees one way or the other. Okay, so they're going to not just move straight up and down, they're also going to kind of come in angles. So neat. Okay, and then we set that rotation equals to the direction. Okay. Their velocity equals vector 2 rand range 150.0, 250.0, 0.0. Okay. Mob.linear velocity equals velocity.rotated direction. Okay. So here we're creating a vector, and we're only randomizing the x. And so then we're setting the linear velocity. So velocity is how fast we're moving. We're saying its overall velocity is equal to just this velocity rotated by the direction. So even though we just set x here and 0, it's going to rotate that to then make it so it's moving that fast along the direction we specified. Okay, and then add child mob. So we just add it. Okay, why pi? Oh, yeah. Here's their explanation of the whole radiance thing. Blah blah blah. There's also town. Blah blah blah. Oh, interesting. Okay, most things don't define that. Alright, if you're more comfortable working with degrees, you'll need to use... Oh, so they have some helper functions here if you wanted to use degrees. Although, really, once you get used to radians, it's not too bad. So I just recommend sticking to radians. Because, like I said, you can always kind of think about it like that. Now, if you need, like, some arbitrary angle, like, 37 degrees, well, yeah, you can't just kind of do that one in your head real quick. So then maybe using these are useful. Alright, testing the scene. Let's test the scene to make sure everything's working. Add this new game call to ready. So we call new game to kick everything off. Okay, I need to save. Alright, let's play. Let's see what happens. Oh, did we blow up? Debugger, child process. Alright, it seems like we missed something. Oh, that's what we need. Because we had set that other one, I think. Wait, what do we do? If you've already set another scene as the main scene, you can right-click down here, maybe? And set as main. Okay, let's see what happens now. There we go, that's what we were missing. Alright, so... Alright, we're not really getting anything, so I think we may have missed something. Alright, so first let's double check that these are named right. So on score timeout. Oh, we probably... I was thinking it may do it automatically, but we probably need to actually do it directly, don't we? Oh, that's neat. It adds little icons to tell us that it has a signal attached. That's cool. This is probably what we're missing. Okay. And the names are automatically the names that they're lining up, so we're good to go there. Connect. Okay. That's probably what we're missing. Let's restart. Okay. 1, 2. Oh, there we go. Nice. Oh, look at that. That's pretty cool. So we have swimming. Ah, I died. Oh no, I'm dead. I'm dead forever because we have not added anything that lets us play again yet. Alright, that's pretty nifty. Alright, next. Alright, heads-up display. Let's make a HUD. Alright, so final piece is our user interface, our UI. To display things like score, a game over message, and a restart button. Create a new scene. Alright, new scene again. Okay, and add a canvas layer. Other node. Canvas layer. Alright. Okay, switch to 2D. Alright, we'll go ahead and save it. I'm just looking to see if they mention a name for us to save it as. Boop, 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 boop. Okay, we're just gonna, we'll call it HUD. This canvas layer seems too generic. So, note to self, if they say drag canvas layer scene somewhere, drag the HUD scene. Oh, never mind, they did that right there. If we had renamed this and then hit save, they would have already said HUD there. Okay. Yep, stands for heads-up display, and information display that shows on top of the game. The canvas layer node lets us draw our UI elements on a layer above the rest of the game so that the information it displays isn't covered up by any game elements like the player or mobs. Excuse me. I was about to say it's getting late, but it really isn't. I don't know why I'm yawning. Alright. Canvas layer node lets us draw our UI elements on a layer above. I read that. The HUD needs to display our score, game over, get ready, start. Okay, basic node for UI elements is control. To create our UI, we'll use two types of control nodes, label and button. So those names are pretty standard and pretty familiar to anyone who's ever worked with like HTML or something. So nice and standard, or even like Unity and stuff also use those. So they're pretty universal. Label's just generic plain text that you can't really do anything with. Button is a button. I think everyone, even if they haven't used a computer, knows what a button is. Alright, create the following as children of the HUD node. We're going to make a label named score label. Label. Score label. Alright. Going to do a label. Whoops, I had label. message. Okay. A button named start button. And a timer named message timer. Okay. Click score label. Alright. Type a number into the text field in the inspector. So inspector text 1 to 1000. We're going to go for a big score. Alright. I'll zoom in so we can see it. Alright. The default font for control nodes is small and doesn't scale well. There is a font file in the asset, so we're going to put that in. To use the font under theme overrides, oh, there it is. Okay, under theme overrides, under fonts. Okay, we're going to do new dynamic font. Okay, click on the dynamic font you added, and under font data, choose load. Okay, and then fonts. There's supposed to be a font in here, I thought. Click load and select the blah 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 font. Okay, why isn't it showing up? Oh wait, hang on. Did I do under font data? Oops, come back. Nope. Alright, let's see. Oh, here, font. There we go, font data. Load. Okay. There we go. Alright, TTS pretty standard format. Size of stuff you got. Oh, come back. There we go. Okay, click on the name, font, blah, blah, blah. Okay, so under set the size property under settings to 64. There we go. Okay. Once this is done, on the score label, you can click the down arrow next to it, choose copy, paste, then paste it into the two. Okay, so let's see. So we hit the down arrow next to the font icon property. Click copy. Paste it into the other two control nodes. Okay, so paste. Okay. I imagine since they call this theme overrides, there's probably a way to create a theme so you don't have to copy paste it every time. But that's probably a little more advanced. Okay. So anchors and margins. Control nodes have a position and size, but they also have anchors and margins. Anchors define the origin, reference point to the edges of the node. Margins update automatically when you move or resize the control node. They represent the distance from the control node's edge to the anchor. So these anchors are what I was talking about when I was talking about docking. The anchors would like anchor it to the top or anchor it to the bottom or left or right or center or wherever. Okay, arrange the nodes as shown following. So let's put in some text here. Dodge the creeps. Looks like we want to enter. Looks like we want center align. What? I'm not doing my drink. Okay, that's why I use a lid. Alright, let's zoom out a bit, mouse wheel. Alright, so there's the blue. So we'll kind of get it in the center. Let's see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Almost center. Okay, and then center this up here. Okay, and then okay, and here, layout, top, wide up. Let's line the center. Text 0, yeah, have whatever text. Layout, top, wide. Okay, where's the layout? Layout. Oh, I just realized there's a search here. Layout, but I don't see layout. There's none called layout. Um, Top wide. Is that an anchor maybe? No. Margin, direction. Huh. I don't know what layout is. Interesting. Oh, there's a layout. Oh, neat. Alright, top wide. Oh, nice. So it stretches it all the way. Cool. Okay. Yeah, I was about to go hunt for something like this. It's always nice to have aligned things because you don't want something to be almost center but be like 2 pixels off, because it, even if it's like, only off center by like this much, you'll notice, or someone will notice, and it'll drive them nuts. Okay, so let's see. So here we're going to do an H center wide. So I guess that's horizontal center and then wide. All right, center auto wrap on, which I just manually typed it, but we'll use auto wrap anyways. Okay, and then if we put it on one line, it'll still wrap. Actually, that's a little clean. Oh, that's interesting. Good to know. So it doesn't. So notice the difference. See how dodge the is shifting a little bit, because it's actually putting this space in there. So when I'm here, there's an extra space, and I could go delete that space and it'll go back to normal. But when it auto wraps, it gets rid of that extra space for me. So that's good to know. All right, and the start button, we're going to do text start, layout center bottom. Center bottom. Okay, so they have it all the way on the bottom now. Huh, they don't in their image, but... Oh, do they? Yep, they use margin. Okay. So, margin. So the margin, just like in JavaScript, the margin is how far away from wherever it anchored. And probably, yeah. So when we use those, it's actually creating anchors for us. So 50.5 and 0.5 means it's anchored in the center, basically. Okay. So top minus 200, and bottom minus 100. Okay. So I guess the margins are controlling the actual top of the element and the bottom of the element. So having the difference between them is our height, which would be 100. And then we're 200. The top is 200 from the bottom, from where it's anchored, and the bottom is minus 100. Or actually, it's probably not where it's anchored, because our anchors are the same here. It probably means 100 from the bottom, negative 100, 200 from the bottom. Okay. All right. On the message timer, set the wait time to 2. All right, so 2, and set one shot to on. So I imagine it didn't really explain it, I don't think, on the other where we used one shot, but I believe that one shot just means it triggers once and then stops. Trash can. And then not one shot means it just keeps going and going and going and going forever. I'll just keep repeating. Okay, now add this script to the HUD. Alright, so we need to add a script. Okay. Get rid of that. Alright, so signal start game. Start game signal tells the main. So this will be what we use for our button, I imagine. Okay, so function show message text. Message.text equals text. So this is just telling it to show our message. Timer.start and what text to show. Okay. This function is called when we want to display a message temporarily, and it's gonna probably hide then when the start timer runs off, or we'll make it. Alright, show game over. Alright, so show message game over. Okay, here's a new thing. Yield message timer timeout. So wait until the message timer has counted down. Okay, so that's just a wait there. Okay, yield is used for some other things at some other places, kind of similar, but it's at least the root of the word yield is the same as like when you're driving. It means yield to other stuff. Wait for that other stuff to finish. So in this case, it's gonna wait until message timer finishes. Message timer show game over. Show message game over. Oh, I see. Okay. So we're going to show message temporary. So it's going to wait until we're going to show getting over. Then it's going to wait, and then it's going to go back to the start screen. So dodge the creeps. And so here they did a new line with no space. That's that whole thing we saw. So if we have auto wrap, that should also work. We'll find out. Okay. And then yield get tree dot create timer 1 timeout. So I'm guessing that means we just added a timer that waits 1 second. Yeah, that's pretty much what the comment says. So not one of the timers that we created over in the tree, just some other random timer. Okay, and then we'll show the start button. So after the game over, we're going to say dodge the creeps. We're going to wait 1 second, and then we'll show the start button. Okay, that's cool. Call when player loses, it'll show game over for 2 seconds, then return to the title screen after a brief pause, show start button. Okay. When you create a timer for a brief period, an alternative to creating is blah, blah, blah. Okay, so that's what I just said there too. Alright, so now we're going to make another one. Func update score label, hit enter so I can't typo it, score, so. Alright, so it looks like in GD script we do have to explicitly cast numbers to strings, so that's good to know. Alright, this function is called by main whenever the score changes. Connect the timeout signal of message timer and the press signal of start button and add the following. Okay, so this is where we messed up last time, so we won't mess up this time. We're going to go to signals. I did start button first, so we're doing pressed. Okay, on the start button pressed, and then also here we're doing message timeout. Wait, message timer. There we go. Timeout. Okay. And now, alright, so start button dot hide, and we emit a signal called start game. So I'm sure we're going to hook into start game then. Okay, and then message timer, we're going to hide the message. Okay, so that was, we started it here, and then when it runs out, we hide it. So that's how we hide it, okay? Alright, so connecting the HUD to main. Now that we're done creating the HUD scene, go back to main. Okay, so we saved HUD, flip back to the main tab, alright, and then go back to main, instance the HUD, so how did we do that? Did we just drag? I think we just dragged. There's a different way we could do it too, but I think we just dragged. Okay, so we made the HUD. Okay, screen tree. Alright, now we need to connect the HUD functionality to our main script. Alright, in the node tab, connect the HUD start game. Okay. Signal to new game. Okay, which that function we already made. Okay. Oops. Oh, it's just. Okay. Alright, cool. I like that we have these little indicators that tell us the signal is there. That's really cool. Okay. Alright, verify that the green connection icon now appears next to blah blah blah. It reads my mind. Alright, in new game, update the score display and show the get ready. Alright, so updating new game. Apologies. I don't know why I'm so yawny. Score, alright, and then HUD.show message get ready. Alright, and let's see here. So we'll show that, and we'll set, okay, so I don't think the order really matters on those. And I like to split things up a little. Okay. In game over, we need to call this corresponding HUD, so game over, alright. HUD.show game over, alright. Finally, add this to the score timeout. HUD.update score. Okay, now you're ready to play. Alright, so let's try this out. Alright, get ready. Oh. It didn't wait for me to start. Okay. If you play until... Okay, so... Let's see, is that something I goofed? Or did they... Not that. So let's see. So ready. So really ready shouldn't call new game anymore. Did they tell us that and I just, because I skim, I missed it? really clicking the button. Shh. What is this? Go away, ad. I can't click my button. That really annoying. Okay. Alright. Quick lesson, how to delete ads. Right click, inspect element, mouse up until you find the top thing that selects them all and hit delete. Ad removed. Next. Okay, finishing up, background. Okay, I'm just skimming real quick because I wanted to see. Okay. Oh, wait. No. Okay, so yeah. So I may have missed it in the code, but it's not coming forward. So let's figure out. It's really, let's see. So in main, new game shouldn't fire there. Or wait, new game sets it up. The start timer starts things. So I don't think we want that. We want to wait until we hit the start button. So we did do press on start button press. So start button hide emit signal start game. Okay. Oh, we didn't hook up the start game. Or did we? Start game. New game. New game connect signal. We did actually do that. I think we just need to delete that, which it may have told us or I may have missed it. Okay. So now I think it should wait. So I'm just waiting a couple seconds. Okay, seems good. Start. Oh, and it still shows 1,000 there. So let's go. We will change that back to 0. Inspector text 0. Okay. Save. Alright, let's try this out now. Alright, dodge the creeps. Start. Get ready. Alright, let's see. Alright, well, I am terrible at this game, but it works. Cool. Alright. Let's see if I can. I think my high score is 7. Alright, broke the high score. Not by much. Alright, pretty cool. Alright, let's see. What do we got left to finish up here? Alright, finishing up. Alright, default gray background is not very appealing, so let's change the color. One way to do this is to use a color rectangle. Excuse me. Make it the first node under main, so that it's drawn underneath everything. Alright, so add child, color rectangle. Alright, create. Needs to be the first, because it sounds like they render things going top to bottom, so things on the top get rendered underneath things. It's just like if you were like using paint and you're using multiple paints, you put a streak of green and a streak of red. The green is now under the red. So it's just like that. So that's a nice way to do it. Some will have like a special like z-index or something, but it's usually nice to do that. All right, so we'll just stretch this out. Or actually, can we do a layout full rectangle? Nice. So now it's anchored to all the sides. Oh. And it says it right there. All right, and we'll set a color. So we could also use a texture rank to set a background image, but we don't have a background image, so we'll just use the color. And we're going to use the blue I like, unless it's totally glaring, and then we're going to pick something else. Let's see. And it's kind of pretty glaring. Not totally glaring, so we'll go with it. Alright. Okay. Alright. Sound effects. Sound and music can be the single most effective way to add appeal to the game experience. In Game Assets folder, they gave us House and a Forest Loop for background music, and Game Over.wave for when the player loses. Add 2 audio stream nodes. Okay, so audio stream player nodes. So I guess that one. It doesn't say 2D or 3D, so we'll go with that one. Okay. Name one of them. Can I just Control C to duplicate? No. Copy. Paste. Kinda. don't know if that's easier than the other or not. Alright, music. Can I hit tab to rename the next? Nope. Okay. Death sound. Ominous. Alright. Alright, click on each one, click the stream property. Alright. And click load. Alright. Okay. So this was music, so that'll be the background. Okay, and then the other will do the death sound. Load. What is quick load? Let's go look what quick load does. Quick load. Oh, that's neat. It just kind of searched for anything that can work. That's handy. That is indeed quick. Alright, to play the music, add music.play in new game. Alright. So, flip back to our script. New game. Let's put it on top. Music dot play. Alright. And music dot stop and game over, so it's only going to play when the game's actually going. Okay. Finally, death sound in game over, so we'll add that after. Alright. Okay. So, give me just 1 second. I'm going to turn it on so we can hear the audio on my desktop in the stream. I normally keep that muted, so if I get any notifications, you guys won't hear random things. But, let's see. Hopefully you guys can hear this. Hopefully I can hear it. Hopefully it won't be super loud. Here we go. Okay. Oh, that's pretty nice music. Alright, let's see. Alright, what was my high score? 10? Can I... nope. Alright. Alright. I was making noise, though, when I died. Let's see if we can hear our death sound. Yeah, there we go. Kind of feels like something out of Link or something. Out of Zelda. Alright, cool. In 1 moment, let me mute my desktop again so you don't get any random weird blasts. Alright. So... neato. Alright, since the game is played with keyboard controls, it would be convenient if we could also start the game by pressing a key on the keyboard. Yes. I love when keyboard-controlled games let me keep my hands just on the keyboard. That is always a preference. Alright. Do this with the shortcut property of the button node. So that's in HUD. So start button. Alright. In the previous lesson, we created 4 input actions. We'll create a similar, so we'll go do our input map again. So project settings, input map. Let's make a new one. What do they want us to call this? Start game. Okay. And we're going to hit play. We're going to do a key, I believe. I did key last time. And a key mapping for enter. Okay. So we start the game with enter. Alright. In the HUD scene, select the start button and find its shortcut property. Shortcut tooltip. Oh, so if you mouse over it, I guess it'll tell you the shortcut. Here we go. Alright, new shortcut. Click the shortcut item. Shortcut. Second, select new input and met action. Okay. Click that. And then action, we type start game. Kind of wish it gave us an autocomplete here. That would be handy. Okay, finally, okay, now when we start. Okay, so now let's go test that out then. Control S to save, play. Alright, so enter. Yay! Alright, let's see. What's the high score? 10? Let's see, can I beat it? Nope. I think I'm getting worse. Alright. Now when you start the button, you can click, and with that, you complete our first game. Woo! Completed our first game. Alright, we're not making a 3D game today. We're going to stick with 2D for now. Oh, that's kind of neat, though. Now I kind of want to make it. It can jump on the stuff. Alright. We're not going to do 3D today, though, because I want to focus on 2D. Alright. So I'll go ahead. I'll upload this to the repo, just because I always do. You can also grab, in this case, their official repo. So there was a thing, yeah, here. So you can grab this. I'm gonna upload ours just in case you want to grab our copy, although I think our copy is identical to theirs. I am going to, however, add a README file just to make sure we give credit to them, because it's always good to give credit. And I need to make extensions visible so I can change that to MD. MD is short for Markdown, which is really popular for like documentation stuff, like GitHub will show it. And basically what it does is it lets you make like formatted nice text in a really streamlined way once you get used to it. I'm just curious if Godot has a MD editor, or at least can open an MD file, and I don't even see it showing anything in here. Res art. Is there a refresh button? No. Okay, so it doesn't seem like it can do. Actually, I'm going to close and reopen it. Maybe it's just some editors get really grumpy when you change files outside of here. Or actually, can I do no new? Create new thing either. Could create a new script, but new file manager. Okay. All right, that's okay though. So we'll just open it in Notepad++. Good enough. Won't be able to preview it here, but this is going to be simple. All right. Go dot. What did they call it? Sample demo project. Let's call it go dot 2D demo project. Let's see. Go dot demo 2D demo project we created during the stream. Tutorial to create your own can be found here. Link to this. And official demo repo can be found here. And I guess that's good for now. Okay. We'll leave. Let's make sure. So also when you use art made by other people, like the fonts, it's good if they ask for it to make sure you have the license in there. So we do have the license. Let's just open up the license, make sure. And license under. Okay, it's an open font license. All right, so as long as that's there, we should be okay. Yeah, people that make open source assets for us to use are awesome. So if you make any assets, fonts, art, sound, you guys are awesome people for sharing that with us, because it is really awesome for making games with. Okay. Alright, so that's good. So, and let's hop on over to GitHub. Make this full screen again. GitHub. Make a new repository. Alright. Godot 2D demo project. Godot 2D demo project we made in the stream. Public, create repo. Copy this. Normally we cloned a repo, but this time we're just making it from scratch, so we don't need to remove origin, we just need to add origin. Git bash here, git init dot to make a new repo, git commit dash 8, or we'll have to do add dot, git status, everything should be green, good, git commit. Actually, is there any... Oh no. Okay, I don't actually think we need to commit the dot import or dot mono. Let's actually go check. Godot has a tutorial on how to commit to Git. because usually in any type of project there's files you want to ignore, because they're built, so there's no need to put them in the repo and make it all bloated. So let's just okay. This is actually for contributing to Godot itself. I don't want that. Let's see. Let's just try this. Godot.getIgnore. Project.getIgnore. That's really all we need. If we put this stuff in the getIgnore, then we should be good. A collection of useful getIgnore templates. Alright, Godot. Here we go. Okay, so yeah. So they do leave out the import and they leave out mono and a couple other things. Alright, so we'll borrow this. Thank you, Yeldham Dev, for providing that to the contributors. Much appreciated. Alright. So I'm going to make a new... Doesn't matter because I'm going to change the extension. .get ignore, and it doesn't actually have an extension. Or get ignore is the extension, depending how you want to look at it. Paste that in there. Alright. So now, since I already added those, I'm just going to do get reset hard head. And it doesn't work because I haven't made a commit. Boo. So we'll do rf /star forget. Oh no, it is rm. Get rm. RF is what you add when you want to really delete something. Come on. Dash R. There we go. Jeez. Wait. Following changes. And dash F to force it. Alright, thank you. And unfortunately that does actually delete them, but that's okay because they'll come back. Alright, and then same thing for .import /star. Okay. Yeah, because those are ones we don't need, and they just end up causing bloat, and can in fact cause issues, because some things may need to be built for each individual computer, so it's best to not have those. Alright, we still have an import.gdignore. What is there? Yeah, that says ignore everything, so we'll just go ahead and manually remove that. It probably skipped it because it has a .i, which is the Linux and Mac convention for hidden files. And so a lot of things will ignore them unless you're very explicit when you say deal with this. Okay, so there we go. So now those are all gone, and now we will add hours. Okay. Alright, oh, and actually, let's go. Let's add to the README. We'll just say copyright. Copyright Godot. Put a link to their website. Because we don't want to try to steal any credit from them. We are just sharing what we've done. Alright, I want to link to the regular website. All those go there. There we go. Alright. There we go. Okay. Status. Alright, add that modification. Get status on screen. We're happy. LP2D demo. Yes, alright, we're good. Get remote, add origin. Copy this again. Copy. Paste. And push -u origin master. Alright, there we go. Cool. Alright, so now I'm going to go ahead. I'm going to end the stream and then start it right back, so don't take off if you happen to be watching. I'm just going to kind of create a nice line, and then when we pop back on in 2 seconds, we'll start on our project. So here we go. See you in a second.